Hi everybody, we're back and this is our favorite part of the day, math. So, I'm really taken by this here. We have a couple of math pages here. I'm going to tell you straight up, man, this is so easy. You're going to be done quick. But the first one is a task and it says Finn and Easy. Well, sounds like Easy-Bella.
Yeah, one of our dogs.
Yes,
That's her
our
nickname.
dog, Isabella. Easy.
Sometimes you can hear her barking in the
Yes,
background.
and if you guys are in the class, you remember you sat in a Team Bella. Easy Bella. Okay, so that was cute. It says
Hey, and I just want to point out, Finn is the name of the actor who plays Mike on Stranger Things.
True.
So I just thought that's interesting too. You guys can be aware of that. I'm sure a lot of you guys already know that. Okay, go on.
Okay. Multiple representation page, practice number sense, strategies, and fluency. And then lesson 7, subtract unlike fractions. This is too cheesy easy. Mr. Schmidt, I think we are going to have this done quick.
Cool.
All right.
That's awesome because it's Friday.
Yeah. Let's go ahead and make this up. Okay, so we've already done all this. So here we are. Okay. Okay, it says, Finn and Izzy consumed the items in the cart below.
Well, it says in the chart below.
Oh, I'm sorry. In the chart below at lunch. What is the difference in the amount of sugar between Finn and Izzy's drink, candy, fruit?
And guys, I just want to give a shout out to Christian because his science project was about the amount of sugar in different items. So Christian, good job. That in our thumbnail shows a picture of somebody's similar science project. So
okay, so I'm what is the difference in the amount of sugar between Fizz and Izzy's? Are we? I'm kind of confused, Mr.
Well, as soon as I see the word difference, I know, okay, we're looking for a difference, which means we're going to have to subtract something eventually.
Yeah.
Between Finn and Izzy's drink, candy, and fruit. So this looks like 3 different problems.
That's what I'm thinking.
The difference in their drinks, the difference in the candy, and the difference in their fruit.
So.
3 subtraction problems.
Okay, so we can handle this. So let's do drink, candy, and then fruit. Okay. So can we...
I can't go down.
No, we don't have any. Okay, so we can do this right here. Let me go up and get my trusty pen. Okay, so what are we working with today? You know what, guys? I'm feeling kind of green today. Okay, so let's do the drinks. So I'm gonna be all over the place, guys. So right here, I'm gonna do drinks because we're doing 3 problems.
Their charts are really large.
Yeah.
So we don't have much workspace here.
So over here for Finn.
You guys could use notebook paper or something.
So for Finn, for his drink, I have 1/3. And then for Izzy, I have a 1/4. Okay, I'm sorry that it's kind of messy and small. But it says the difference. What is the difference in the amount of sugar? Okay, so we need to do some subtraction then, right?
Mm-hmm.
Okay. I'm seeing a problem here, first of all, because I need some common denominators for 3 and 4. So, I'm going to do this least common multiple. Nah, I'm going to do the skip counting this time. So, I'm going to say 3, 6, and then 9. I almost went to 12, guys. 9, and then 12. And then for 4, I say 4, 8, and then 12. And we can still see that 12 is our common denominator. So, we're going to put 12. And 4 times 3 was 12. We could have just multiplied. And so 1 times 3, because what we do to the denominator, we do to the numerator. And 3 times...
I hope you guys can see this.
I know. 3 times 4
we noticed on some of the videos people
12.
are clicking that they disliked it. So I hope it's not because
1 times 4 is 4. Yeah, we're trying. Okay. Yeah. It just doesn't give us a lot of room. Maybe I could have done it down here in the middle of it, but... Okay, so we are subtracting Finn's drink and from Isabella's. So we have 4 minus...
Mrs. Schmidt?
Yeah.
I have an idea. Why can't maybe we can like zoom in a little bit temporarily?
Yeah.
I know I'll have to
maybe
find my
so.
place again when I do that, but...
Okay.
So let me see where we are. Okay,
Yeah.
that's down low. Okay, so
Okay. Yeah,
so
that
now
does.
at least they can see better.
Yeah, that does work out better for us, and it makes it easier for me to work at. So 4 minus 3 is going to be 1/12. So if I come here and I say drinks, and I'm talking drink, I'm going to say difference. I'm just going to do this, guys. And I'm going to say the difference is 1/12. Okay? So let's just do that. And so now we are working on the candy, I guess.
Yeah, and let's see
Okay.
if we can...
I'm
let
gonna
me
put
see
my
if we
pen
can
down,
scoot this
so-
over a little.
Perfect.
Cool, and then we can go like this.
Okay, perfect. So now I'm going to try and work on the candy.
Oh, but the 1/2 is out of view. So let me zoom out again, so they can see the whole chart, like both charts.
Okay. We can work this. This is fine. I'll just go ahead and work it down here.
Okay.
Okay.
Let me scroll one more time.
Okay.
Just to get... Okay, there we go.
Okay, so what I'm going to do here is I'm going to go ahead and put my stuff up here. I'm going to say difference of candy. Organize myself. Okay. Difference of candy.
Just watch those corners.
Okay. Thank you, Mr. Schmidt.
You guys can't see the corners I'm talking about, but it's
they're
the part
there.
of the screen that we're
It tells
capturing.
us where I need to stay. Okay, so I have 2/3 and 1/2. So what I'm going to do is I'm going to come right here. Let's see. I think I can do it right here.
Do you need more room? Want me to roll down?
No, I think I'm okay. So I like to write it regardless of the fact that it's already there. 2/3 and 1/2. And again, I'm finding difference, so I need to subtract. And again, what I'm looking at is I need a common denominator. So skip counting again. I'm going to say my 3s. I can say 3, 6, 9. And then for my 2s, I'm going to put it right over there. 2, 4, 6. And I can see that my common denominator is 6. Easy cheesy. Okay? Okay, so 2 times what? Well, it was 3. So 2 times 3 was 6. So 1 times 3 is 3. 3 times 2 was 6. So 2 times 2 is 4. Okay? So I'm still subtracting. 4 minus 3 is going to be 1. So it's 1/6. So the difference of the candy is 1/6. All right? Now I have fruit. So I'm going to say difference of fruit. Difference of fruit.
And we're talking about the difference in the amount of sugar in each item.
Yeah. Yeah. But
I mean, we already know that. I'm
categorized.
just
Yeah. But
bringing
thank
it
you.
up
Thank
again.
you. Yeah, we're not talking about the fruit necessarily. We're talking about the sugar in the fruit.
Right.
But categorizing, are we enter the soda? Yeah. Okay. So, I have 1/8 and 1/12. So I'm going to try and do it right here so I think I can have a little bit more space. So I'm going to say 1/8, and I think I'll still have enough room.
I think I want to scoot down so in
Okay.
case you have to go lower.
Okay, thank you. 1/8 and 1/12, because I noticed last time I got small again. Okay, so I again need a common denominator for 8 and 12. So I'm going to come over here this time, and what I'm going to do, I've been doing skip counting, but I think we need to remind ourselves that we can use least common multiple. Okay?
And kids need practice.
Absolutely.
And you use the least common multiple to find the common denominator.
Absolutely. Yeah. Okay, so for 8...
They also call it the LCD, the lowest common denominator.
Mm-hmm. The 8 and the 12. Okay. So, we need a
The lowest prime number is 2.
Yeah, it is. It is 2. And we need to remember, because we like, oh, well, okay, 4. 4 is not a prime number, so we don't ever want to do that.
Yeah, because you're going to need to break it up.
Yeah, yeah. So don't ever put a 4 out here, because we're not looking at what number will go into 8. We're looking for the prime number.
Factors. We're looking for the prime factors.
The prime number that will go into there. So this prime number goes into 8. It does go in 4 times. We remember 4 is a composite number, so we have to box it.
Yeah, and guys, this process is called prime factorization.
Yes, it is. And so 2 goes into that composite number 2 times. And so my 2's are my prime numbers, and we have found the prime factorization right here for 8. And it equals 2 times 2 times 2. Okay? 2 times 2 times 2. All right, so now 12, I'm going to do the same thing.
Start with 2.
Starting with 2, and it goes in 6 times. 6 is composite, so I'm going to box it.
2 again.
And 2 again. 2 goes into 6 3 times.
And booyah.
3 is prime. Awesome job, Mr. Schmidt. Okay, so we have 2 times 2 times 3. Okay, I think I have some pairs.
Yeah, we do.
Okay, so I see a set right there.
And in this case, that means we're only going to need 1 of those.
Yeah, so I always go ahead and scratch off the top one, because I only need 1 in the pair. And I have another set, so I'm going to scratch that one off too. Now, if you guys will notice, this is not a pair. This is a 2 and this is a 3. Although I have another digit in each of the groups, they're not the same, so I can't do that.
And we have other 2's, but they were already paired up.
Yeah, so we can't do that. So, but we're doing least common multiple. So remember what that means. We don't leave anybody out. We take everybody. So 2 times 2. So what we're looking at is we're looking at 2, this one here, times this one here. Okay? And then times this 3. So we're going to cross him off. We've already got him. And then times that 2, okay? And so we've gotten them all. All right, so 2 times 2 is 4. Okay, so we're done with those. And then we're going to multiply it by that 3. 4 times 3 is 12. So we're done with that, okay? And then we're going to multiply that by 2, okay? So we're done with all of this. What is 12 times 2? It equals 24. So, back up here, what is our common denominator for 8 and 12? It is 24. And you could find it with skip counting as well, but we want to show you as many different ways as possible. And besides that, you may be asked to do it in a specific way.
5th graders should know how to do that.
Oh, definitely.
And guys, if you don't know how, that's why you're learning. You're learning how.
Absolutely.
If you do know how, awesome.
Yeah, 12 times 2 is 24. So if I multiplied by 2 here, I'm going to multiply by 2 here. And so 1 times 2 is 2. 8 times 3 gave me that 24. And so I'm going to say 1 times 3 is 3. And again, remember, I'm doing difference. So I am subtracting. 3 minus 2 is 1. And it is still the same denominator. My denominator never changes in addition, subtraction. So the difference of the sugar in the fruit is 1/24. Okay?
And that leads us to this question at the bottom.
Okay. So now,
I know we'll have to go back and look at the results, but we need to read this question, right?
all right, yeah. So it says, explain who consumed less sugar in total during lunch. Mr. Schmidt.
Well, one thing that it's easy to know the answer to this because every problem was a subtraction problem, and we always started with a larger fraction subtracting a smaller fraction, whether it looked that way at the beginning or not. So I already know who consumed the most or the less.
Yeah,
the least.
because we can see, I'm going to tell you guys right out, we can see it was always, is this Finn over here?
Yeah, let's go up and make sure.
Yeah.
Finn, yeah.
Okay, so we always subtracted what Finn had
And we
and
subtracted Izzy's number.
Izzy's from it.
So that means Finn started out with more.
Yeah, Finn always
Every time.
Finn had more. So we know he actually consumed more sugar.
Yeah.
But we
could
know
work
that.
it out.
Yeah.
Mm-hmm.
I'm going to show you guys how to do this. So I'm just going to set it up 1/3, 2/3, and 1/8.
Okay, where do you want to set it up? Down low?
Down here.
Okay.
Okay, so I need to go down a little bit further.
I just didn't know how much you needed to see on the chart.
Okay. Yeah, I can see it right here. So I have, for Finn, I'm going to let you guys do this. But Finn, he had 1/3, and he had 2/3, and he had 1/8. Okay? And so in order to figure out exactly how much sugar he consumed, I would need to add that. And then for Izzy, it's going to be the same thing. And then you can compare. So over here, Izzy had 1/4.
I almost thought that was a number. That looked like 224. I was like,
Oh.
I was like, wait, where did that number come
Oh,
from?
yeah.
Okay.
Yeah, true. And 1/2. And then 1/12. Okay. So, again, we need to find out how much each one of these guys actually consumed. So, what would be the best strategy here? I think we could do one of them and then let them do the other.
I would first look at how we made common denominators up above.
Mm-hmm.
I see here in the first one we made 12ths.
Mm-hmm.
In the second one you made 6ths. And then we made 24ths. And I realize, hey, all of those can be, you can get a common denominator with those three numbers.
Mm-hmm.
I could double the 12 and get 24, and I could multiply times 4 to change 6's into 24. So I'm thinking we could probably get these all to be 24ths.
I think you're right.
And
Because
let's see
if
this one. This one we wouldn't even have to, right? Although if we're having 24ths with Finn's number, then we should have 24ths over here.
Yeah, that would make it so much easier.
Yeah.
Yeah.
So I would be thinking about how can I make all of these denominators be 24ths?
Yeah, so let's think about this here. So let's make this 24, 24, and 24, because you're right. And if we did our skip counting or least common multiple, I assure you,
sure,
it's going
you could
to
work it out that way. And I know sometimes teachers assume, or they jump ahead. And I was kind of jumping ahead. I do that a lot in my mind.
Oh, of course.
I'll see like, oh, these all can go
they're
to
all
24.
24.
But we need to make sure you guys know how to do that.
Yeah. So I'm going to make this easy. I'm going to prove to you. That's a 3, and an 8. So if I came over here and I skip counted, I got to stay inside here. So I could say 3, 6, 9, 12, 15, 18, 21, and then 24.
And guys, would you have to do it again for the next 3? No, because we already have a list for 3, right?
Exactly.
So for the second fraction, we wouldn't need to do that again.
Yeah. So 3 and 3, we got it. So let's do the 8s. So we have 8, and then we have 16, and then we have 24. Guys, it's right there. So see, it is there. And you know what the good part about this is, Mr. Schmidt? I can look at this here and I don't even have to think about it. 8 times what? How many 8s are there in 24? 3. Yeah. Super easy. So 8 times 3 was 23. 1 times 3 is 3. And so then the 3. 1, 2, 3, 4, 5, 6, 7, 8. Right? 3 times 8. And then 2 times 8. Okay? So 2 times 8 is 16. 3 times 8 again, because we've already done this. And so then 1 times 8 is 8. So in order to figure this out, we would just add our numerators. So our answer would be the numerator over that 24.
Yeah. And guys, what do you see? I see 16 plus 8 already equals 24. So it's going to be an improper fraction.
Yeah, 24 plus 3 more is 27, correct?
Correct.
Yeah. But you know what, right now? I think that all they're asking is who consumed less.
Sure.
So I'm just going to leave it that way right now.
And sometimes I just like to do it for fun. You know,
yeah.
I like to solve it different ways and see which way works.
Yeah. Well, we can go ahead and do
no,
it because that's
I'm
the
not
proper
saying that,
way.
but do you think they need any help with Izzy, or are they good?
I think I'm not going to do Izzy for you.
Okay.
I'm just going to remind you that you can still use 24.
And I would, just because you could also use 12, but that wouldn't help you when you get over with the 24.
Then you're going to have to compare them.
Especially
so
since
you're gonna have to do it again anyway.
It's 27 over 24, so you can't divide by 2. So
yeah. So I would leave it this way until we finish this, and then we could compare.
Right.
But yeah, you can skip count. You can find the least common multiple. But yeah, I'm going to assure you, 24 goes. 24 is going to work
4
for you.
times 6, 2 times 12, and 12 times 2.
Yeah,
sure.
Yeah. So I think you guys have this, and then just see, well, who had more sugar or who had less.
And we already know, right? Because
we know.
We were starting with Finn's number every time and subtracting.
But I want to remind you, it asked who had less sugar. So please make for sure you read it correctly.
Right.
All right, guys, let's go ahead and move on.
And maybe we need to zoom back out a little.
Yeah.
To fit this in.
Yeah,
there.
that one was just a tight little squeeze there.
So we're off track a little bit here. So let me get here. Let me see. Let me see. Okay, I gotta go down here. I gotcha. Sorry, guys. There we go.
Yeah, we're having a little technical difficulty.
Yeah, sometimes. It's because we zoomed in and out.
Yeah, we were playing with it, trying to help out here. Okay, folks, so you know what I'm looking at? This is the same thing as what we did yesterday. Different numbers.
Simple numbers, right?
Yeah.
They're really low.
Yeah, and you know what? We did so much of that just a few minutes ago.
With harder numbers.
Oh, yeah, a lot harder. So, it says draw, picture, solve. I'm going to let you guys do all of that. So, we have 1/4 plus 1/3. You can just go back to the previous page and figure out what the common denominator.
Find common denominators, yeah.
Okay, and then down here on the number line, whatever your common denominator is, hint, hint, it's going to be 12. You are going to go ahead and put your numbers using the common denominator of 12, and then add, so you're going to, whatever this is, you're going to put it on here, and then you're going to add the second number to find out how many 12s you have.
Sure. And
write your story. So that one was easy. I'm not going to do that because that one was too easy. Okay. Subtract unlike fractions. You can draw models to help subtract fractions with unlike denominators.
Hey.
I like this.
And I just want to say one more thing about the previous one.
Sure.
If you guys are in my class and maybe you need help with it, maybe it wasn't too easy for you still, send me a note on Dojo and I'll help you. Okay?
Absolutely.
Yeah.
Hey, yeah. You know what? If you send us a note through Class Dojo or something, say, you know what? I'm sorry, I just didn't get it. We're not gonna. We're not gonna
judge you.
No, we're not gonna.
We'll help you.
We're not gonna call you out or anything. But we might be able the next day to go back and say, I remember that somebody had an issue, so let's review that.
Exactly. Okay.
We're gonna do that, guys. Yeah. That's what we're doing.
Sure.
It's still school.
So I just want to say, I don't want anyone to feel bad if somehow you feel like you didn't understand.
No, I want you to practice it, but if you don't know it, please let us know.
Yeah.
Okay, so you can draw models to help subtract fractions with unlike denominators. So I'm looking here, I've looked at this already. This is 3/4, so they came over here and they wrote 1/4, 1/4, 1/4, which equals 3/4, okay? Minus 1/3. So it's just a 1/3, so it's right here, okay? Sorry, they had a 3/4. Okay, so it's right like that. Okay, I'm doing my own writing.
All right.
Okay, find the least common divisor. So they've changed the.
Wouldn't it be the least common denominator?
Yeah, Some people call it divisor, but it is denominator.
I think LCD stands for least common denominator.
Yeah, and it's the same thing.
It also stands for liquid crystal display, but with fractions, I think it's the least common denominator.
Yeah. Okay, folks. So, multiples of 4. So
but you know what? You're still right, because what do you do with a fraction? You divide the top number, the numerator, by the denominator, so it's still a divisor. So it is. But kids, when you're doing a math problem, you would normally call that the least common denominator.
Yes, absolutely. Okay, multiples of 4. So they did some skip counting. We have our multiples of 4. So we have 4, 8, 12. And then 3s, we have 3, 6, 9, and 12. So again, we know our common denominator is 12. So the least common denominator of 3/4 and 1/3 is 12.
And see there, you can see that least common denominator and least common multiple are interchangeable.
Exactly.
It's the same thing.
Yeah. That's unfortunate that they do both of them.
Mm-hmm.
It is a little confusing, but they are the same.
Yeah.
Okay, so now what we said here is if we were going to find the common denominator, it would be 12. Well, in modeling, what they did here is what they're saying is I need to take this. I'm going to erase this here. And so what they're saying is I need to take this and I need to divide it into 12. Okay? So how can I have 3? So I'm thinking, help me. Okay.
You split that into 4 parts.
Yeah, okay. Too many.
Yeah.
Huh?
She counted the lines, guys. We don't count the lines, right?
Yeah, I know. Shoot, my rolls.
She's getting tired. We've been at this for hours.
Yeah, I'm thinking Okay, so let me go back. Okay, so I need to divide this into 12 pieces. So I already have 3. So that would be 4. That would be 5.
You know what? You know what's wrong?
What?
Look at what's wrong. Oh. Okay, they're showing models for 3/4. Okay, I got you. So the fourths need to be divided into what?
3s. Okay.
Yeah, because if we had another fourth that's not showing on this model, then we would have 12 parts.
Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9.
And if we look at the model they already have at the bottom, down lower, we can see now we match.
Mm-hmm. Mm-hmm.
Okay.
Okay, and then over here, this has to be divided into 12s.
Into 4 parts.
So it's going to be divided into 4 parts.
And guys, that's like when you multiply the denominator at the bottom by 4, right? To get a common denominator, you'd have 12.
Yeah. Okay. So what they have done is they've taken.
Let's draw an arrow like there to there and there to there to show.
Yeah.
Yeah. How they got to that.
Yeah. Okay. So I want to come up here and I want to get a different color. And we haven't used that one. So what we have here is we're taking. I'm going to do it like this here. Whoops. So I'm going to go These things here, what we're saying is this is the same as this here. Okay? And so what they have done, as you can see here, is they've taken out 1, 2, 3, 4 12s. 1, 2, 3, 4, which is exactly what they did down here. Okay? So how many 12s are left?
Is it okay if I scroll down a little now?
Absolutely.
So they can see that? Okay.
Okay, so how many 12s are left? So what we've done is we've taken this and we've set it on top. So we've eliminated this out of here. Okay, so we took this and put it over here. Took it out. How much is left? 1, 2, 3, 4, 5. So what we're left with is 5 12s. And so it's right there, 5 12s.
And it's on the left too.
Mm-hmm. Okay.
Okay, ready?
Yes. So now let's talk about the first one, and then I'm going to let you guys get this business under control. So we have 3/4 and 5 12s. Easy cheesy, we've already done this. So what was the common denominator for 4 and 12? Well, we said it was 12. We put it down here. So now we have to figure out that numerator, which they had up there. What did I do to, if I'm going to call that 12, see, this is why I always like to do it this way. I just want to remind you guys. 4 times what gave me 12? It was 3, correct? So what is 3 times 3? It is 9. So this equals 9 twelfths. Now, over here, 12 times what gave me 12? Well, it was just 1. So 5 times 1 is 5. So that means the 5 goes right here. So what is 9 minus 5? It's 4.
Now, they do say in the instructions, write each difference in simplest form.
Yes.
So we know we're not finished yet.
No, because 4 twelfths. So now what I need to do is I need to find a number that I can divide both of these with.
And guys, if you already know, like a lot of the kids will already know how to simplify that without even writing anything. If you already know, go ahead and write it.
Yeah, easy cheesy. So, Mr. Schmidt, what do you think?
Well, I see that 4 and 12 have a common factor. I already know what that is. But, I mean, if we didn't know, we could list out the factors, right?
Yeah.
4, I could list out. Well, I just, it's hard. Go ahead and write down how you want to do it. Because for me, I already see that 4 is a factor of 12.
Yeah.
And it's a factor of its own self. So you could divide both of those numbers by 4. That's what I would see.
Yeah.
And that's just because I'm really familiar with my multiplication facts. So I see that 12 and 4 have 4 in common.
Yeah. So if I'm thinking about, this is the way I like to say it. 4 goes into 4, I know that. So I always look at my numerator and I say, will my numerator go in there? Is there anything I can multiply 4 by and get 12? Yes, there is. And I know I can do it here. 4 goes into 4 one time. Well, how many times does 4 go into 12? 4 goes into 12 3 times because 4 times 3 is 12.
Remember, guys, whatever we do to the top, we need to do to the bottom.
So, yeah. So, I was trying to put it in the middle, but I should. Okay, so it is actually that way. What I do to the top, I do to the bottom. Okay? So, what I'm looking at is my simplified fraction is 1/3. Okay? Are we good, or do you think we need to do more?
Well, let's look at the bottom ones and see if anything looks challenging.
Subtract,
Maybe, 8 and 3, we worked with 8 and 3 up above. I'm looking at number 9, and I see what would be the common denominator for number 9? We had some of those up above. We realized that 3 is prime, and when you factor out 8, you're going to have to use all the 2's. It'll take 3 2's, right? When you factor out 8, it's 2 times 2 times 2, and then times 3, because that's what we would end up doing.
Yeah.
We did that up above. So that would be 24. We would have to multiply 8 times 3, basically.
Yeah. Let's take a peek at that one, Mr. Schmidt. I like to always put them like this here, guys. Working, you remember we just said when you work horizontal across there, this is kind of confusing to me. So I like to do it like this here. Because if I'm going to find my common denominator, I need to find one. So what is going to be my common denominator for 8 and 3? We already talked about that.
And so let's go up.
We did say it was 24.
Yeah, well, let's go up to where we did that. Let me see.
Yeah, it's
there's
24.
3 and 8 and 24. So a lot of times, guys, even if you're doing a test or something, you can go back to problems you've already done and say, hey, I already solved that.
You know what? A lot of times we always like to use the same numbers over and over. So, yeah, it is. But if you didn't know, you could work it. Yeah. So, but it is 24. Okay. And so 3 times 8 was 24. And you can always multiply your denominators, and that works too, but you're going to need to simplify. I'm sure you will. Okay, so 3 times 8 was 24. So 1 times 8 was 8. 8 times 3 was 24. So what I multiplied by 3 down here, so I'm going to multiply by 3 up here. So 7 times 3 is 21. What am I doing? What is my operation? It is subtraction. So I need to subtract. What is 21 minus 8? Well, 20 minus 8 is going to be 12. But I have one more, so I think it's going to be 13, don't you?
It is.
All right. So I think it's going to be 1324. Okay. Now, I think we hit this problem before.
Something like it.
Yeah. And so we talked about this and we said, well, we're done because 13 is a prime number.
Well, as long as...
Yeah,
Yeah.
remember?
You gotta check.
Yeah, it is. 13 is a prime number, but we better make for sure that it will not go into 24.
And I just want to add that I already knew that we wouldn't be able to reduce this because we had to use every single factor. We had to use all the 2's from the 8, and we had to use the 3. If you have to use all of the factors, then you're not going to be able to reduce it. When you could reduce it is if you had like when we cross out one of the factors. When you do that, you're reducing it at the time you cross out that factor. So I'm just saying, I already knew since we had to use all the factors, there's no way to reduce it.
Absolutely. So that kind of sums up our day. Okay. So now when he's talking about the factors, remember what he was doing was he was finding the least common multiple or the least common denominator.
Well, I want to show what I do.
Okay,
sometimes.
I'm going to let Mr. Schmidt
when
have
I'm not
it.
when I'm not doing prime factorization, another way I could do that. Okay, so let's do another one. Let's do 20 and 5. Okay. Let me see. I already know. Okay, guys, let me undo that mark I just made. Okay. I already know that a common denominator here would be 20. And a lot of you advanced math kids, you'll know that already, right? So what I would do is I would just list out my factors. Okay, so I know 1 times 20 is 20. And then, let's do this. Okay, and then I have a comma, and then what would come next? Could I use a 2? Sure. I could use 2 times 10. And then what? Could I use a 3? No.
No.
Could I use a 4? Sure. I could use 4 times 5. And then I'm already back to the 5, so I've used all, those are all the factors of 20.
Yeah, and the thing is when you get to our
when you get to
digits,
the middle,
our digits are only one digit.
Yeah.
You can't do it. You're
so
done.
5, here's 5. We just have 1 times 5. And why do we only have those two numbers? Because 5's prime.
Yeah.
What's their greatest common factor? 5. Okay, let me see. So let me see. So we have 20 and 5. And how many 5s would we need to get to 20? We need 1, 2, 3, 4. Okay, so we need 4 here. 4 times 5 to get 20 down there. And then that means we would have to multiply the top times 4. And 2 times 4 is 8. So this would turn out to be 9 minus 8 over 20. So, and I want to show you guys that too. You can rewrite this actually like this. 9 minus 8 over 20. And then that would equal 1 over 20.
Very good.
So that's another way to do it.
Yep. Awesome.
And if it's confusing, remember, send us a message on Dojo.
Yeah.
Say, Mr. Schmidt, I have no clue what you were just doing.
Yeah, I haven't. This is awesome. I haven't seen this in a long time. I haven't done this way in a long time. So that's cool.
Well, because 5th graders usually do the prime factorization. Yeah.
But this is awesome. I haven't seen that in a while. So that's good for me too.
It's just, and it's also good practice just to make sure you can practice all your factors, right?
Yep.
And be really familiar with your multiplication facts.
Very nice. All right, guys, we are done. It is Friday. We are done. You guys have a great weekend. Enjoy. Be safe. Be kind to your parents.
Mrs. Schmidt?
Yes.
I'm hoping we can, maybe this weekend, put a video about making some quicksand.
Oh, that'll be awesome. Quicksand.
Oh, otherwise known as oobleck.
Oh, my gosh.
Yeah.
Okay, guys.
Okay.
Well, you guys have a great evening. Take care.
We love you.
Bye.
Bye.